Hi there! Today we will have a class about magnetic field and right hand rule. Do you want to go further? See you in the board. So the first concept that you gotta master is this. What is a magnet? A magnet is a piece of material that has an invisible force or that has an invisible radius that if I get close to this radius or to this area, this invisible area, a force will be acted. For instance, it will be repelled because it's getting close. Look at, there's no touching nothing. It's an invisible radius, right? Versus is the same. Just for Coulomb's law, it's the same is repelling, right? Let's change, let's switch the faces. Now it's getting close. Look at, it's getting close, and now it's being attracted, right? Why this is occurring? Because the Coulomb's law. You have to recognize this invisible area, okay? Look at, this is the same as repelling, right? Never is gonna be touched, okay? It's not gonna be touched. So if you wanna understand this, why this event is occurring, see you on the board. Let's recall the Coulomb's law. What is the Coulomb's law? That the same charges are repelled, plus repel, minus repel, and different charges are attract. That's the main point of the magnets, the Coulomb's law, okay? It's being applied on magnets because a magnet has poles. Has two poles, the north and south pole, the positive and negative. A magnet does have poles, magnetic forces. What is a magnetic force? A magnetic force is that invisible line. It's an invisible line that is conforming this, okay? Now, this invisible line is called magnetic force, and the area within this space is called magnetic field, okay? Magnetic force is the border, is the line, okay? And the magnetic field is the area within that line, okay? Also called the space where the magnetic force acts. That's why this is the magnetic line or the magnetic force, and the area within this is called magnetic field, okay? It's quite simple to understand. And there's something, because you need to understand that there's something perpendicular, okay? Perpendicular, that's the degree. What is a magnet? A magnet is a piece of material that has a invisible force, okay? This invisible force is being produced by invisible lines. Those are called magnetic lines, okay? So we have already understood this. That's why it has invisible, look at, it's an invisible radius, it's an invisible force. You cannot see, but in fact, there are lines that are, 90 degrees, right? That's why it is occurring perpendicular to the move, okay? It's perpendicular to the motion. Now, if I switch positive negative or negative positive, the charges has to be different. Is going to be a track, okay? That's the base of the Coulomb's law. Now, in order to master the magnets, we already know what do a magnet have. A magnet has poles, also has magnetic forces that are invisible forces or invisible lines, and also it has a magnetic field that is the area within that invisible lines, right? This is the line, this is an invisible line, it's called magnetic lines or magnetic force, and the space within this is going to be called magnetic field, right? So why we have a right hand rule? Because the magnetic field, okay, the magnetic field, this area, the force of this area, or the measure of this area that is in Tesla, this is the equation, is almost the same than this. In fact, they are the same, okay, but here we are finding B and there we are finding F, but in fact that's the same equation, okay? Relate this is the same equation. So you just have to understand that you have to know what is the Q. Q is the charge. V is speed. Sinus, what is the angle? I have to provide this information, this and this, and also the force in order to find what is this magnetic field, okay? If I want to find what is the force, because it's the same equation than this, we can use this and we can just multiply this. Charge multiplied by the speed, multiplied by the field amount, multiplied by the angle. That's magnetic palm force, okay? That's how you can find what is the force, what is the field force, what is the current force of this, and what is the motion, where is the motion occurring due to this is the right hand, okay? This is applying in this way because the motion is here, okay? Motion, field, current. If this electron is moving toward right, okay, we will have this diagram, okay? The force will be here, okay? Motion, field. This is, it's going to be the force. In the upcoming videos, we will develop examples in order to have a better understanding of this, okay? Now, let's just understand that. And this is equal because when this electron, so let's understand this part, because when this circular and round wire, it's the meaning is that there's an electron going through a wire. This is the wire. This is a thin wire, and this is a widest one, okay? What do we have to understand here? That an electron flowing or going through a wire, it will produce also a magnetic field, right? Magnetic field, okay? Now we have to know what are the two equations that we are using to find the magnetic field. This one and this one, okay? Now, that's all. That's all. You don't have to know nothing apart of this. Just write this down and see you in the next videos that we will be recording or that we will be solving certain exam.